So like I said, our test for this is on Friday as of right now. Today we're doing more application. Tomorrow we're doing writing equations. Wednesday, Thursday will be review days. And then Friday will be our test. Okay? So, first problem today. One number is a square of the other. Their sum is 42. Find the two numbers. So we're looking at two numbers here, right? One of them is a square of the other. Well, if we don't know either of them, let's let our first one be x. Okay? So I'm just going to let one of my numbers be x. Okay? That's what we do in math, right? We let it be a variable. Okay? Well, the other number is a square of x. So it's x squared, right? So we get x and x squared. So we have those two numbers. Their sum is 42. Addition, right? Sum means we're going to add them. Equals 42. So x plus x squared equals 42. Find the two numbers. In other words, solve for x. Okay, well we have an x and an x squared term, which means we should probably get one side equal to 0. Okay, if it was just x squared, we get that by itself. We have x and x squared. So to get one side equal to 0, I'm going to subtract 42. And I'm going to put x squared first. I'm just going to rearrange them. X squared plus x minus 42, I can't write, equals 0. From here, there are two ways I could go about solving for x. I could either use a quadratic formula, or I could factor. If you can factor, I would highly suggest doing that. It will save you time. If you'd rather just use quadratic formulas, you just do the same thing over and over, that's fine as well. It's up to you. Okay? So I'm going to factor. I need numbers that multiply to negative 42 and add to positive 1. And? 7 and negative 6. Good. X plus 7, x minus 6. Now, using the zero product property, I can take each of those and set them equal to 0. X plus 7 equals 0. X minus 6 equals 0. Solve them both. I get x is negative 7. I get x is 6. Well, hold on a second. It told me that my number should be, one should be like a normal number, and the other one should be a square of it. Are 6 and negative 7, is one of those a square of the other one? No. So what's going on here?
You're wrong.
I'm not wrong. That's only what x is. There's going to be two sets of numbers that actually work out for this problem. So if x is negative 7, x squared has got to be 49. So my two numbers in this case would have been negative 7 and 49. However, 6 also works. Well, 6 squared is 36. If I add them together, I get 42. If I add them together, I get 42. So not only is there just one set that works, there's two sets that work. You need to have both of them. Okay? Does that make sense? Oh, we just got both sets of numbers there? Yes? No? Okay. Okay, let's try the second problem here today. The area of a rectangle is 84 square inches. The length is 5 more than the width. Find the length and the width. Well, let's start by drawing a picture. Beautiful picture, I know. Thank you.
Wow.
So that area of that rectangle is 84 square inches. Okay? The length is 5 more than the width. Well, what are my length and width going to be then? And? X and x plus 5. Okay? Now, how am I going to solve for the length and the width though?
X times x plus 5 equals 84.
Perfect, right? We know the area of a rectangle is length times width. So I can do x times x plus 5, and it should give me the area they gave, which is 84. Right? My length times my width should give me my area. So, solve for x. I'm going to distribute x into here. X squared plus 5x equals 84. Well, get it equal to 0, right? I have an x squared and an x term. So subtract 84. X squared plus 5x minus 84 equals 0. Well, this looks a lot like the last problem, right? We can either quadratic formula or factor. Now I'm going to factor because it factors nicely. So I need something that multiplies to negative 84 and adds to 5. So take a second, think about it. What'd you get?
7 and 12.
Both were positive?
No.
Negative 7? Okay. So x minus 7, x plus 12. Same thing. Take n, set them both equal to 0. X minus 7 equals 0. X plus 12 equals 0. Add 7. I get x equals 7. Minus 12. X equals negative 12. Okay, well, let's stop for a second. Let's just think about this. Is 7 a good side length for a width? Yeah, that's fine. Is negative 12 a good side length? No, right? We can't have a negative number, so I can go ahead right away, cross off negative 12. Okay, so I know 7. 7 inches is going to be my width. So width, 7 inches. What's my length going to be then? 12, right? 7 plus 5, x plus 5. So my length is 12 inches. Good. Those two problems weren't so bad, were they? No. All right. Any questions so far? We good? Ooh, we have a rocket problem. I love this problem. So I get to draw. I'm not a good drawer. So, an amateur rocketry club is holding a competition. There's cloud cover 1,000 feet above the ground. If a rocket is launched with a velocity of 315 feet per second, use the function negative 16t squared plus initial velocity times t plus initial height to determine how long the rocket is out of sight. So let me just draw a picture here first. Okay. So here's our rocket. Right, that's on the ground. It is being shot in the air. And it's going to come back down, right? Do you all agree with that? Okay. Well, there is cloud cover at, what did it say, 1,000 feet. We want to know how long the rocket is out of sight. In other words, we want to know that distance. We want to know how long it's in that distance. How could we maybe find that? Think about it. Is there a way we can figure out how long it is up there? No. So we don't want to know that distance. We don't care about that distance, how long it is. We just want to know how long is it up there. How many seconds is it out of sight? Well, what if we found out how long it took to get to this point and how long it took to get to that point, and then couldn't we figure out the time in between them? Right? Wouldn't that make sense?
Sure.
If I launch a rocket and I see how long does it take to get to this point here at 1,000 feet, and then how long does it take to get to this point here, also at 1,000 feet, could I find out the difference in between them? I could. So to do that, not only do I need to make my equation, but I need to set my equation equal to 1,000. So we set our y value, our function, always represents the height. So if I know I want it when it's at 1,000 feet, I should set it equal to 1,000. So I get 1,000 equals negative 16t squared plus, hey, what's my initial velocity? 315. So plus 315t. Do I have an initial height?
Yes.
Well, technically it's 0, right? The rocket starts on the ground. So, do I need to put plus 0? No. That's my equation right there. Right? We said if it's going to equal a height, I know I should set it equal to 1,000. That's when I figured out when it's going to be there. So, how should we solve this? How can we go about solving for t? We're going to use quadratic formula. Before I can do that, what needs to happen? It needs to equal 0. So I'm going to subtract 1,000. 0 equals negative 16t squared plus 315t minus 1,000. So now that I have it in standard form, now that it's equal to 0, I can go ahead and solve for t. And it should give me my 1 and 2 points of how long it takes to get to there. Okay. Do we have any questions before we go to solving? Do we all understand why we're trying to do this? Yes? No? Okay. Then, let's solve it. So, quadratic formula. Negative b plus or minus the square root b squared minus 4ac all over 2a. So, once you have it set up, it's all about just doing calculations. So I get negative 315 plus or minus the square root, oh, some big numbers, 99,225 minus 64,000, excuse me, over negative 32. Okay. All I'm doing is the calculations. I'm putting each piece into my calculator separately. Okay. That's how I like to do it. If you want to put it all in at once, good luck. So, negative 315 plus or minus the square root of 35,225 over negative 32. Once I get to this point, I can break it apart. Yes, Andrew, you got a question?
No.
Okay. I'm going to break it apart. So I'm going to get negative 315 plus the square root of 35,225 over negative 32. And I'm going to get negative 315 minus the square root 35,225 over negative 32. Okay. Now, like I said before, be careful how you put it in your calculator. I would always do the numerator, hit enter, then hit divided by negative 32. Otherwise, it might mess up. If we mess up on our parentheses, we don't close a parenthesis under a radical, things like that. So once you get those two answers, please round to 2 decimal places. Did we get an answer for either of them yet? Alvin, did you get one of them?
The adding is 3.98.
So 3.98 seconds. Okay. Natalie, did you get the other one by chance?
Yes. I got 15.71.
Okay, so 15.71 seconds. So what that's telling me, if I go back up to my picture for a second, is it took 3.98 seconds to get to here, and then it took 15.71 seconds to get to here. So how can I figure out how much time elapsed between the two? Subtract them, right? So I get 15.71 minus 3.98. We get approximately 11.73 seconds. So the rocket was out of sight above the clouds for approximately 11.73 seconds. Okay, does that make sense? How we did that and why those numbers worked out like they did? Are we sure? Okay. Are there any questions at all? Okay, we're out of here, what, 25? Okay, the next one, we are gonna skip this one because I think it's a dumb problem. I'm just being honest, right? A carnival ball on a bell doesn't go up at a parabola, it goes straight up. It's stupid, it doesn't make sense for us. Okay, so we're talking about a quilt quick. They did a lot of the math for us, we just gotta solve it. So if we're making a quilt, the quilt is the red part here, right? The border around it is gonna go all the way around, it's gonna make it into a bigger quilt. It's gonna be the blue quilt now. We need to figure out how wide to make that quilt, or how wide to make that border. To do that, we need to find the area of the border and then solve for x. So they did this a little bit for us. They took the area of the blue, which is 4 plus 2x times 5 plus 2x, and they subtracted the area of the red, which would be 5 times 4. Okay, so they took the blue minus the red. Okay, do you all understand that? Is this on your paper already, hopefully? Right? Yeah. So then they just did the math. They foiled out this part. They folded it all out, and it was equal to 10 because he has 10 square feet to use for the border. Okay, so he knows the area is going to equal 10. So he found the area, got it equal to 10, and then got it equal to 0. Because he had an x squared term and an x term. So he subtracted 10. So we're at the point of, we need to solve for x to find what our border is going to be. Or how wide it's going to be. How would you go about solving this? Now there's only 5 minutes left, so I don't think we're actually going to go through this. But I just want to know, how would you go about solving this? 2 ways. There's 2 ways you go about it. Quadratic formula or factoring. Okay? Now, like I said, we only have 5 minutes left, so I think we're going to skip this one as well. Is there anyone that wants to go through doing quadratic formula for this? Is going to be like torn to pieces if we don't. Okay. We will skip this one. We can come back to it on one of the review days if we need to. But I also want to talk about something else. So I hope subscribe. The answers should be